that we have already studied. So in order to understand this in a better way, always I would advise that have a kind of an idea about the internal structure, the behavior of the internal structure, and then it will be much easier to understand why these earthquake, volcanoes, etc. happen. Now, for your exam perspective, this is going to be relevant for your prelims. Now, in prelims, you do find questions associated with, for example, this year also UPSC had asked a question about this, about the seismic waves. Waves and their basic properties. Basic properties of volcanoes and the types of magma. Also, the basics of earthquakes in general. Shadow zones is another area. Then you have this portion being frequently asked in the mains exam as well, and the questions again from this area are also repeated multiple times. So in the mains examination, the questions that you will find is basically going to revolve around shadow zones of the different waves, then global distribution of earthquakes and volcanoes, volcanic hotspots, and mantle plume. Okay, human induced seismicity. These are few of the areas from where UPSC will ask you a kind of a mains type question. Okay, and before moving ahead, there are many of you who have been harping around the same question, so I'll address the question, and that is about note making. So listen to this very carefully. I'll not take your individual names, but I will address the query in general. Try to understand that. I understand each of you will have a slight nuanced form of the problem, that I don't know how to make notes, or whether should I make notes or not, or if I make notes, should I make notes of this topic or not, or only geography. So understand first of all the general aspect. Why do you make notes? What is the purpose of making notes? The purpose is to help you revise in a better way, where you feel that before the mains examination or before the prelims examination, when you have to finish the entirety of the revision of the whole subject in, let's say, 1 hour or 1.5 hours, in that case you cannot expect yourself to be opening up and flipping through the books at that point of time. That is why people start preparing notes. Now, when you are preparing notes, in that case, always the notes has to be very concise. Now, how do you prepare notes? So there are various different types of candidates out there. Few of the candidates, you will notice, they have opened up their book and they start writing in the name of note making. They are not note makers, but rather they are photocopy machines. So don't be a photocopy machine in your life. There are enough photocopy machines in the world. UPSC is not seeking for another photocopy machine. If that would have been the case, UPSC would have taken the test for a typist or a stenographer. UPSC is seeking your involvement as an IAS or an IFS or an IPS officer out there. You are supposed to be the decision maker, not a photocopier. So when you are preparing or reading any particular topic, study it carefully at that point itself, try to understand the various different nuances, and then write it on your own without looking at the various sources of information in a piece of paper, in an A4 sheet of paper, in as concise a manner as you can. Ideally, for a topic, let's say, such as continental drift theory, one A4 sheet paper, one side of it should be enough to be for the entire continental drift theory to be depicted as a note format. Okay, so that is something which you can follow in the session as it is proceeding. There, running notes is something that you can make where certain important facts you can note, and that is going to help you significantly at the time of revision as well. Otherwise, you have candidates who always have that kind of a grievance that so much text is not written in the PPT, I need more text. So if you are facing that issue, you can make running notes in the class itself. Otherwise, what I would suggest is, after you have attended the session, do revise and then prepare topic based notes. Each of the topics that you find which are worthy of making a note, make a note for that. Make a note for plate tectonics and the different types of plate movements that happen. Try to create it on the paper on your own. Unless and until you put the pen to paper, many of the concepts will be, you will be having that thought that it is clear, but the concepts will never be clear. So that is very, very important to put some amount of writing class as well. Okay, so now we start the discussion with earthquakes, volcanoes, faults, and faults. So, first of all, we will take a look into earthquakes. Now, before entering into the portion of earthquakes, volcanoes, etc., so we have seen that the planet Earth, while it was getting created, there was a significant amount of heat which was trapped in the interior. And that amount of heat is still trapped in the interior of the planet. Now, that heat tries to escape every now and then, that residual heat tries to escape from some other form or some area or the other. But also, you have to understand that it is that heat from the inside which creates the plate movements, which ends up creating the convection current. So, all the various different events that you observe in terms of rising of landmass, subsidence of landmass, movement of landmass, creation of an earthquake, volcano, etc., all of them are the forces acting from the interior. And those forces acting from the interior are initiated because of the heat present in the interior. So the forces acting from the interior of the planet, that are referred to as endogenic forces. So endogenic forces. These are forces acting from the interior. These endogenic forces are the ones which are responsible for occurrence of various events such as earthquakes, volcanoes, creation of faults, the different types of faults which are created. All of them are created because of these endogenic forces. So now we come to the portion of earthquakes. What do we mean when we talk about an earthquake? So it is, in simplest of the terms, the shaking of the earth's surface. That shaking of the earth's surface, whenever it happens, we refer to it as an earthquake. Now, that shaking of the earth's surface will happen because of varying reasons. A multitude of factors are at play. So, here, when we say that there is an earthquake which has occurred, that means in that region, the earth's surface has shaken up significantly. Maybe it has caused some amount of damage. But then, why is it that it is shaking? So, naturally, under general circumstances, we have seen, be it in the case of a convergent or a transform plate boundary, whenever you have large rocky pieces of the crustal portion or the portion of lithosphere, whenever they will try to move with respect to each other, what will happen? They will always face some amount of resistance. They will always face incredible amount of opposition. So, as two objects they start to rub against or they try to rub against each other, what will happen? They will face that obstruction, so their movement will be stopped. So, all that energy which is forcing them to move, that energy will keep on piling up, and eventually it will show a sudden movement. And whenever that sudden movement happens, it leads to the shaking, it leads to an earthquake. So that is where the shaking of the earth's surface is an earthquake in simplest of the terms of the earth's surface. Okay. Now, here the opposition that these rocks, the opposition or the obstruction or the resistance that the rocks face, they will be facing it somewhere in the interior at certain depth. That depth might be 60 km from the surface, that depth might be 100 km from the surface, that depth even might be around 400 km from the surface. If, let's say, a convergent plate boundary is there where one of the plate is undergoing subduction, and it is here where the plate is facing some obstruction while going down, so that is where the energy will be released. So, wherever the energy is released, which leads to the shaking of the Earth's surface, that is referred to as the focus of the earthquake. Okay. So, when you talk about the focus of the earthquake, it basically refers to the place where the energy is released during an earthquake. Okay. So, the place where that energy will be released. Now, that place can be anywhere, depending upon what kind of convergences are happening, what kind of faults or cracks are there on the Earth's surface, what kind of movement, if at all, is happening. So, it can happen anywhere or it can happen in different places. It can exist in different places. But then, when you talk about the focus, let's suppose in a particular region, the focus, let's say in the Himalayan region, an earthquake has occurred, and that earthquake has occurred because as the Indian plate very slowly is trying to subduct underneath the Eurasian plate, it is facing an obstruction somewhere at a depth of 60 or 100 km, leading to an earthquake. Now, how will you pinpoint where the earthquake has occurred? For the general reference of the public, what will you tell them? That an earthquake has occurred underground at the depth of 100 kilometers somewhere underneath the Himalayas. Will you refer it to like that? No. So the point immediately perpendicular to the focus on the surface, which gives you an exact idea about where the earthquake has occurred, that is referred to as the epicenter of the earthquake. That is directly above the region of the focus. Now, in an earthquake, can there be multiple epicenters, or do you think there will only be one epicenter? What do you think? Good. It will be only one, because when you draw a vertical line from the region of the focus, it will lead to only one point. It cannot lead to multiple different points, right? So epicenter for any particular earthquake will only be one. Now, based upon the where the focus lies, you have the classification of earthquakes into different types based upon focus. So based upon focus, you can have shallow earthquakes, intermediate earthquakes, and also deep focus. So shallow is generally observed when the focus of the earthquake is between 0 to 100 kilometers from the surface. That is referred to as a shallow focus earthquake. Intermediate focus, roughly between 100 to 300 kilometers. And deep focus from 300 to 700 kilometers. Beyond 700 kilometers, there won't be any particular focus or no earthquake will occur. Why? Because when you go to a depth beyond 700 kilometers, already the materials are so very dense and compressed that if they face a resistance, they will get deformed. Rather than rubbing and breaking against them, they will simply get deformed. Okay, so that is basically the focus of an earthquake. So again, very quickly, I will recap it. What do we refer to when we refer to as a focus of an earthquake? So that place in the interior of the planet where the movement of the rocks have experienced a kind of a resistance, friction, opposition, which has inhibited their motion. So that sudden motion which happens where there is a release of energy. So that point of release of energy in the interior, that is the focus. Now, here, the point on the planet surface immediately and the shortest distance from the focus, that represents the origin of the earthquake. That is referred to as the epicenter for any particular earthquakes. Okay. Now, I hope that is understood. Now, here, when we talk about the shaking of the earth's surface which happens during an earthquake, now you have to understand that all these detailed understanding, all these detailed information that the earthquake has occurred at this particular depth, at that particular region, this much amount of energy has been released, all those details that you find in the news headlines, all of that has developed quite recently in the past 50, 60 years, that is to say. But then, since the 1900s, in the early part of the 1900s as well, when you would study the earthquake, earthquakes used to be classified based upon the destructive potential that they had, the amount of destruction that they would cause. Because all of you would have experienced this, that not every earthquake is the same. Few of the earthquakes, when they occur, you read it in the newspapers or read it, or in many of the cases, you come across it in social media itself nowadays. So when you come across that piece of information, you don't even get to feel it, and you only read it in somewhere else that okay, in that place the earthquake has occurred. So there are certain earthquakes which do occur which we don't even feel. There are certain earthquakes which do occur which leads to significant shaking of the earth's surface, causing a lot of destruction. Every day across the planet, hundreds and thousands of earthquakes, they do occur. Majority of them are not even felt by us humans. They can be felt by certain instruments. So earlier, when this classification was being done, that classification was done depending upon the lowest scale of earthquake, something which we have not even felt as the earthquake occurred. Then slightly greater scale of earthquake. So there was shaking of the earth surface, shaking of the ceiling fans, etc., but not major damage. Then another scale of earthquake which has occurred. So this time the trees also started shaking, the buildings started shaking, all of that happened. Then another scale of earthquake means large scale destruction. So that is how the earthquakes used to be classified earlier. But it was understood, upon greater studies, it was understood that look, when an earthquake occurs, the amount of destruction that you observe on the ground, that is not going to be consistent for every earthquake. It is something which is variable in many of the cases. For example, if I give you the example here, let's suppose I have two places here, A and B. Let's suppose the surfaces are similar here. In one case, the focus is at a depth of, let's suppose, 20 kilometers. And in another case, the focus is at a depth of, let's say, 100 kilometers. Let's suppose the same amount of energy is released. Which area will experience more destruction? A or B? What do you think? Always A? How are you guys saying B? I would like to know the logic behind saying B will have more destruction. Anybody, if they can enlighten us, why do you think that B will have more destruction? Any idea? So please understand, more energy would be released. Why more energy would be released? I already told you the same amount of energy would be released in that case. So always understand, if the same amount of energy is released, then this will end up shaking the Earth's surface much more significantly, isn't it? So the destruction which will be observed in A, which will be much higher as compared to the destruction observed in B. Also, destruction is dependent on many factors. Destruction is dependent upon the type of buildings that you construct, what kind of stable landmass that you have. For example, when you consider the sedimentary floodplains, which are deposited by the river, the plain area, let's suppose a region like Delhi. Now, if a massive earthquake strikes those areas, the land in itself starts behaving in a kind of a wave like pattern. The land in itself starts moving like a wave. So the destruction will be almost immeasurable. Everything will get destroyed, everything will get broken. But on the other hand, if let's suppose a region is stable landmass, there is significant amount of rock present, then there won't be that much destruction. So that is where in the mid of the 1900s, it was understood that destruction causing potential cannot be the true parameter of judging an earthquake. We need to be able to judge the amount of energy which is released, the amount of energy released whenever an earthquake strikes. Because eventually, as the rocks overcome that resistance and as they will suddenly move, they will release humongous amount of energy. So that is where you had the inception of a device which is referred to as a seismograph. Seismograph. It is very much like your ECG machine that you would have observed in the medical centers, in the hospitals. In the case of the seismograph as well, you have a roll of paper which continuously comes out, and you have a kind of a pen which continues to move on the roll of paper. Whenever there is a shaking, the pen will also shake, creating a kind of an image there. Just to give you an idea, the ideal or the typical role of a seismographic record, if you will observe here, it will always give you a depiction like this. So that is where, under normal circumstances, the pen will remain in the same place, but whenever there is a shaking, there will always be a vibration, and that will be depicted, as I said, just like your ECG machine that you would have observed, that depicts a kind of a vibration. So this records an earthquake and the energy released. Greater the energy released, greater will be the amplitude of this particular one, greater will be the disturbance, isn't it? So this methodology helped us understand that there can be different amount of energy released at different points, at different depth, at different regions, at different places, at different rock types. It is dependent on differing factors. So overall, the earlier categorization that we talk about, where the earthquakes would be categorized based upon the damage causing potential, that would be referred to as the intensity of the earthquake. Intensity of an earthquake. And what is the intensity? That is classification of an earthquake based upon the damage causing potential. So in this case, you have a proper scaling that grade 1 earthquake, nobody will even be able to experience that. Grade 2, maybe some animals here and there will be able to experience that. Grade 3, we will also experience that, but very slightly. Grade 4, we will experience that, we will feel a slight amount of discomfort. Grade 5, you will have or a scale of 5, you will have basically the objects in your room will start shaking. Grade 6 of an earthquake, so an earthquake occurs where the household items they shake quite vigorously and the buildings also shake. Grade 7, smaller structures they start to fall. So just like that, grade 12 is where a complete destruction and devastation happens, nothing gets left behind. So grade 1, grade 2, grade 3 earthquakes, they are prominent all throughout the planet. Even as we speak now, some or the other place across the planet would be experiencing this kind of an earthquake, because the plate movements are also a continuous phenomena. Somewhere or the other, something might be happening. Now, this scaling is done based upon a scale that is referred to as the Mercalli scale. Mercalli scale. But then we are not able to understand the amount of energy released. So, for that measurement of the amount of actual energy released during an earthquake, so that we understand that how powerful an earthquake was, we will take a look at destruction later. That whether the powerful earthquake will cause destruction or not, that is a different matter. But how much energy is released? So, for that, you had the definition, or rather the depiction of magnitude of an earthquake. So, what is this magnitude of the earthquake? So, it measures the amount of energy released. How? By measuring the amplitude of energy variation that is indicated in the seismographs and on the Richter scale. So, that is how you measure the amount of energy released. So, used to measure the amount of energy released. This is measured with the help of Richter scale. Okay. So, intensity or the damage causing potential of an earthquake is something which is depicted by the Mercalli scale. And the actual amount of energy released is measured with the Richter scale. Why there is a difference? Because the even if there is the same amount of energy released, the destruction caused in different places will be subjective to many different factors. I'll give you examples. Most of you would have heard about the Latur earthquake, which occurred in Maharashtra almost close to around 30 years back. Now, Latur is a region in Maharashtra which was never expected to observe or experience any earthquake at all. So, the geographers, the geologists, they were not expecting an earthquake to occur, and the earthquake was also not very intense. The earthquake in itself was close to around 5 and 5.5 magnitude on the Richter scale, something that very frequently is observed in the region of Himachal, Jammu Kashmir, even Delhi. They do experience around 4 and a 5 earthquake very frequently. So, Latur, being present in the peninsular part of India, the plateau region of India, which is made up of thick rocks, there was no expectation. The buildings which were constructed were so shabbily constructed, in general, as is the case with the construction standard in our country. What do I tell you? You would be more familiar with that, and you would be associating that in your nearby region as well. That the construction standards, they are not to the best. Many of the times, simply, it is stacked up to form a kind of a building. So when that earthquake struck, you had massive destruction, and thousands of people, they lost their lives. Now it was five and a half earthquake. Now the same kind of an earthquake which is experienced, let's say, in other parts, let's suppose in the Chota Nagpur plateau in the region of eastern part of West Bengal and southern part of Jharkhand, it is rarely causing any destruction at all. The same magnitude of earthquake or the same energy of an earthquake occurring underneath Delhi, it will shake up the earth's surface but doesn't cause that much destruction. So the damage or the destruction, it varies. Now, when we talk about the one of the most massive earthquakes that India witnessed in the last century, easily one of the most massive earthquakes would be the 1934 Bihar earthquake, which had its epicenter in the region of northern part of Bihar. You would have heard about the region of Madhubani, Darbhanga, which is famous for its paintings. So that is where the epicenter was. Now, that earthquake is said to have had a magnitude of close to around 8 plus, 8.5 is the predicted magnitude of that earthquake. When that earthquake occurred, now Bihar is even 100 years back, it did not have very lofty structures, it did not have great infrastructure. So, generally, you would have had a simple housing which would dominate the plains. Now, there was so much amount of shaking of the earth's surface, and northern part of Bihar in general, as is the case with the northern plains, is made up of alluvial deposits in general, deposits of soil. So, when the earth started shaking, in many of the areas, the soil in itself gave rise to a breakage where underground water started coming up and flooding the region. So the destruction cause was so immense, more than 10,000 people lost their lives. But then, if you compare that to a kind of a 7.5, 7.9 Bhuj earthquake which occurred in Gujarat, now there, the destruction caused was quite significant. More than 20,000, 30,000 people, they lost their life because the population density was higher, right? So for various earthquakes, even if the amount of energy is the same, the destruction can be very different. So that is why when we talk about intensity, that can never be referred to as the final parameter of classification of an earthquake. That is why, in order to understand an earthquake, you need to understand the amount of energy released in the process. And for that, you have the magnitude. Okay. Now, here, this is the scale of measurement. So, when we talk about Mercalli scale, so it represents the intensity of an earthquake, ranges from 1 to 12, 1 which is not even felt, 12 means nothing is left, everything is destroyed. Then, Richter scale, it represents the magnitude where we end up measuring the amount of energy which is released, and that is expressed in between 1 to 10. Sometimes it is also expressed between 0 to 10, that is zero point 0.2, zero point 0.3, zero point 0.7, but that is something which even the seismographs find it very difficult to detect. But then this Richter scale, this is logarithmic in nature. Logarithmic in nature. I hope we are familiar with the aspect of log and log. At least we have heard about log and log scale in general in our class 10th maths or ninth maths. That is something which is taught. Okay. So here, you don't need to get into the details of it. Just understand what it means is a magnitude 7, magnitude or rather magnitude 6 earthquake is 10 times more powerful than a magnitude 5. A magnitude 7 earthquake will be 10 times more powerful than a magnitude 6. So, in a way, a magnitude 7 is close to 100 times more energy is released as compared to a magnitude 5. right? Magnitude 8 will be 10 times more powerful, more energy as compared to magnitude 7. So here, when we talk about this magnitude, so in general, the earthquakes that are recorded, which don't cause enough destruction, are in the range of around 3.4, 2.3, 4.2, roughly in that range, between 3 to 5 on the Richter scale. Not much damage is caused. When the earthquake magnitude increases beyond 5, that is when the earthquakes start getting severe. Nepal earthquake of 2015 had its magnitude close to around 7.5 to 8, right? Bhuj earthquake of 2001 in Gujarat had its magnitude close to around, again, 7.9. But then here, one is not required to learn these magnitude numbers. One is not required to by heart or ratify these magnitude numbers. This is just to tell you what amount of destruction or the shaking of the earth one experiences. Now here, furthermore, this is the magnitude. That is, what is it that the magnitude measures is amount of energy released by an earthquake is called its magnitude, and it can be measured by the amplitude of the seismic waves. So on the seismograph, you have seen the seismic waves produced. These are the seismic waves which are produced. So by measuring the amplitude of that seismic wave, you get an idea about how powerful an earthquake has been. Now, to tell you slightly greater detail about the earthquakes, whenever an earthquake occurs, okay, here, amplitude, okay, how many of us don't know the meaning of amplitude? Feel free to express. So, in very simple terms, if this is a wave, if this is a wave, the variation from the central point or the central reference, that is amplitude. So, similarly, when we have a seismic wave, greater the energy, greater will be the wave generated. So that will be your, this will be your amplitude. It gives you an idea. So whenever you have a wave, it is associated with a kind of wavelength. So this is what is referred to as the length of the wave, what is referred to as wavelength. This is also represented by what is known as lambda, but don't get into it. So you have a wavelength, you have a frequency of a wave, and you also have the amplitude of a wave. Okay, so that is basically the nature or the measurement characteristic of the wave. I hope that is understood now. Okay, now here, whenever you have two rocks which are trying to move, large rock pieces, kilometers thick crustal plates which are trying to move with respect to each other, the movement will never be smooth. The movement will always face some or the other obstruction. Now, as the movement is trying to happen, first of all, let's suppose, and try this at your side as well. Protrude your central finger outside and then try to move the fists one against each other. You will observe there is an obstruction offered. There's a resistance which is felt. And all the meanwhile, while you're trying to move this hand, there is energy which continues to build up. So it might happen that initially, after let's say 10 years, 20 years, or 30 years of this continuous energy buildup, some amount of this rock gets broken. So there will be slight adjustment. And then eventually the rocks will move. And then finally the rocks will settle in their new places. Every time that they will move, there will be some amount of energy release, some amount of shaking of the Earth's surface. So when you talk about, let's suppose, how it is recorded on a seismograph, basically, here, initially, whenever a massive earthquake occurs, before that, there is a slight adjustment of the rocks. You observe slight shaking. And this can happen a couple of months in advance. This can happen few weeks in advance, few days in advance, or even few hours in advance. When the rocks, they try to adjust themselves, finally overcoming the resistance and finally going for the motion. And then eventually there will be that massive movement or the massive adjustment of these rocks. And then after that, when the earthquake settles down. Again, after that, maybe few hours later, maybe few days later, maybe few weeks later, or even few months later, the rocks, they will again observe a kind of a final adjustment. Right? So this is recorded as the main earthquake. Now, the shocks that you observe or that you measure or that you receive prior to the main earthquake, prior to the main shaking, they are referred to as what? Foreshocks. And the shaking that you observe after the main earthquake, that is what is referred to as aftershock. Okay, so that is basically how you have the earthquake which generally occurs. Every earthquake will have some or the other foreshocks and few aftershocks as well. For example, the April 2015 Nepal earthquake, which had its epicenter at Kathmandu, now it had its aftershocks going around for almost a month later. That means even after a month of, now I'm sure by 2015 you guys would have had that much amount of consciousness to understand what happened or what did not happen. So at that point of time, around 1 month later, 1.5 months later as well, you had the shaking of the earth's surface, which was observed in regions as far as Delhi. Now, that is not a part of the main earthquake. That is not an individual earthquake on its own. It is just the aftershock of the main earthquake, which occurred almost a month back as the rocks are settling down. So, that is basically a characteristic of any of the major earthquakes that you associate with. Now, when we talk about an earthquake, whenever an earthquake occurs, there is release of energy. So the energy released by the earthquake travels in the form of a wave-like pattern, and those are referred to as seismic waves. Okay, so the energy released during an earthquake travels in the form of a wave, and that is what is referred to as a seismic wave. Now, if I ask you a question, let's suppose when we talk about energy, light is a form of energy. Now, if let's suppose do or answer the main question first of all, will this energy be unidirectional, or will the energy when it is imparted will be multidirectional? In the sense, will the energy travel only in one direction, or will it be able to travel in all directions? What do you think? Very good. Energy will always be multidirectional. When you light up a candle, it is not as if only one side of the candle receives light. That light is transmitted in all directions, isn't it? When you put a speaker in the center of the room, that sound will be emitted in all directions. That energy won't be restricted only in one direction, that where I am sitting, that speaker will give me only sound in that. Unless and until you provide some directionality to the light, you provide directionality to the, let's say, sound, etc. So energy travel, when it travels, it is generally multidirectional in nature. It can travel anywhere. Now, now I bring you to another concept. Let's suppose I have this as the planet. Now, there is an earthquake which has struck with a focus at a depth of around 80 kilometers from the surface. Now, here, I'll give you two options. Let me know how the energy will travel. The first option is the energy will travel here closest to the Earth's surface and will shake the Earth's surface, and that is it. And the second option is that the energy will be emitted in all directions, regardless of where it is going, it will be emitted. It will hit the region closest to the focus first. What do you think will be the case when you have an earthquake which is occurring? Good. All of you will agree to that? That it is going to be emitted, energy will be going, is going to be emitted in all directions, and then eventually closest to the surface is where it will strike first. It will strike with maximum intensity. So the energy waves emitted by the earthquake, they also end up traveling in all directions. Those energy waves is what we refer to as seismic waves. Seismic waves. Now, these seismic waves, they are also classified into different types based upon how is it that the waves travel, how is it that they will influence the particles, where is it that the waves will travel. Okay, so let us understand that in slightly greater detail. So when we talk about the seismic waves, so when an earthquake occurs, it releases waves of energy which are known as seismic waves. It is like ripples created in water when you throw a stone in it. How the ripples, they spread in all directions, right? Whenever you throw a stone in water, the ripples will spread in all directions. Just like that, the seismic wave also spreads in all directions. Now, this seismic wave is classified broadly into two categories depending upon where it travels. One is referred to as the body wave, another one is referred to as the surface wave. Now, body waves, they are referred to as the body waves because they travel through the interior of Earth or the body of Earth, right? And then eventually, so understand this. Here, again, I will take the same example. If let's suppose this is the planet, now here is where the earthquake has struck. Now, from here, the energy will be transmitted in all different directions, in all the different directions. But in all the directions, they are traveling through the body of the planet in itself, isn't it? So they will be referred to as the body waves. But what about this region? The region where it will hit the surface first. Let us analyze that region. So let's suppose I represent that particular area. Let's suppose. Let's suppose the focus has occurred here, and amongst the multiple areas where the energy is going to strike, this is the area where it is going to strike with maximum amount and also maximum intensity and also at the quickest time. So when, if this is the surface, if the energy hits it, what will happen to the surface if there is some energy which hits it? Now, the surface, it is a continuous one. It is not as if Delhi is, or let's say Delhi is separate as compared to Noida, Gurgaon. So if there is a shaking of the land surface, Noida, Gurgaon doesn't have anything to do with it because we are in a different state. If there is a earthquake occurring underneath Gurgaon, then Delhi is a different area, so it doesn't have to do anything with it. If there is a shaking here, if there is a vibration here, the land will vibrate here as well. The land will end up vibrating here as well, isn't it? Imagine, just like in the case of the ripples of water. So, if I throw a stone in the central point here, and all of you would have done that. So, these ripples, they will disturb the surface of the water, even though the point of disturbance is only one. But someone or some insect sitting here will also get disturbed. Some insect sitting here will also get disturbed. Some insect sitting here will also get disturbed. Why? Because the surface is getting disturbed. Because the surface in itself is observing the transmission of energy in the wave pattern. So, in a similar manner, when you have the energy from the body waves when they hit the surface develops a kind of a wave like pattern. So imagine if, let's say, this forearm of my hand it represents the land surface. If it hits here, if let's say the energy hits here, now this will start shaking. Now it is not as if only this will shake and the rest of the portions won't be impacted. If this shakes, the entire surface in itself shakes, isn't it? So why is that? That is because the land is a continuous one. So these energy waves which travel through the surface only, they are referred to as the surface waves. When are they generated? When the energy waves from the focus, they will disturb the surface, isn't it? So here, when the energy waves, when the energy waves from the focus disturb the surface starts initiating movement of energy through waves. And these waves, they are referred to as surface waves. Okay, so the primary demarcation is you have the body waves. So whenever the earthquake occurs at a focus, energy will be released, which will travel through the body of the earth, and that is referred to as the body wave. And eventually, also, whenever you will have that energy reaching the surface will be disturbed, generating a wave like ripple effect on the surface itself. That is referred to as the surface waves. Now, let me ask you a logical question now. Whenever you take a look at the various different types of buildings which have been destroyed during an earthquake occurring in, let's say, a region, and 50 kilometers away there has been a destruction quite significant. Now whenever you come across these, that destruction is primarily caused by what? Body waves or surface waves? What do you think? Good. It is always going to be surface waves, because it is the surface waves which generate that kind of a disturbance, and that continues for a longer distance. So all the destruction that you observe is primarily carried out by the presence of surface waves. Let us analyze these waves in slightly greater detail. What do we understand by the body waves? What are the categories of the body waves? What are the categories of surface waves? Let us take a look at them. So here, just imagine in this is the region, if this is the region, so the body waves, if they hit here, then how that entire surface is disturbed, and that how entire surface eventually observes the movement or the propagation of a wave, that is your surface wave. Now, when we talk about the body waves, first of all, we'll be talking about body waves. Okay. Now, for your general studies, you need to be aware of only two types of body waves. Otherwise, there are multiple categorization of body waves. But for your general studies, you need to be aware of only two types. You have the P waves or the primary waves, and you have the S waves. That is the secondary wave. Okay. P wave and S wave. Otherwise, there are other categories of body waves as well. You have PS, then you have PG, SG, P star S, S star P. So you have multiple different categories of body waves. But for your prelims or for your general studies, you are not supposed to go into that detail. So let us understand what these P and S waves are. And by the way, these are emitted, released from the focus simultaneously at the time of occurrence of an earthquake. So they are released from the focus simultaneously. So let us take a look at them. Primary waves, and then secondary waves. Okay. Now, here, wherever the focus occurs or wherever the focus lies, on top of it, there will be rocks, there will be various different types of materials present. So, let's suppose you have the presence of materials, and any matter will have the presence of molecules as well. So, let's suppose here you have the presence of molecules. This year, UPSC had asked a question in prelims directly from the portion that we are covering right now. So it was a direct question from this particular slide. So here, let's suppose these are your molecules. Now, let's assume the focus is somewhere here. This is where the focus is. Now, when the earthquake occurs, energy is released. So the energy is transmitted, let us assume, in this direction. Direction of wave propagation or wave movement. And then here, how is it that it travels is basically the first particle will get disturbed. It will start vibrating. Now, when the first particle starts vibrating, it will consistently end up disturbing the second particle. So the second particle also will start vibrating. That will disturb the third particle. That will disturb the fourth particle. That will disturb the fifth one. That will disturb the sixth one. And that is how the wave moves forward, or the energy is transmitted forward. So each of the particles, they end up vibrating in their own space, thereby disturbing the next particle, allowing the wave to move forward. So in this way, the wave is transmitted forward. Now, can we say that the direction of particle motion in this is the same as the direction of the wave motion? Yes. So how is it that the wave will travel? Wave will travel through compression, rarefaction, just like how the sound waves travel. When you speak, how is it that the sound waves travel? The air gets compressed, again expands, again gets compressed, again expands, and it travels further. So here it will travel or propagate by some compression, then areas will have some expansion, then again compression, then again expansion, and so on. And then in the next moment, these are the areas which will get expanded. The expanded areas are the ones which will experience compression, then again expansion, then again compression, then again expansion. And that is how the wave moves, right? So, wave movement by compression and expansion. Now, in this case, We can say, we can make an observation. Direction of wave movement. Let us make observations here. In the case of the P wave, direction of wave movement. Movement is the same as the direction of particle movement. Okay. Direction of wave movement is the same as the direction of particle movement. Okay. How is it that it moves in one direction? This is just as an example I'm giving you. In reality, it will move in all different directions. Okay. Aditya, my dear friend, kindly refresh your connection in that case. It is something which is absolutely fine from our side. So it is basically going to be emitted in all different directions, okay, that you experience. Now, it is just as an example that I'm showing you to explain that how this wave actually propagates, where the direction of the wave motion is going to be same as the direction of the particle movement. The wave is also moving in this direction, the particle is also moving in this direction. So in this way, the wave movement is going to be much faster. Why? Because both of them are moving in the same direction. So that is why primary waves, they travel at a much faster speed. So these waves travel at much faster speeds. At much faster speeds. Why? Because direction of wave motion is same as the direction of particle. Just like the sound waves. So if one particle gets disturbed, it will disturb the other particle. That will disturb the third particle. That will disturb the fourth particle. And very quickly, it will get transmitted. But this is about solid. When we talk about, let's say, a medium such as liquid or gas, gaseous medium. Now, in the case of a liquid or a gaseous medium, when we talk about, generally, the particles are further away. In solid, they are very compact. In liquids, they are away. In gases, they are further apart. So, in this case, the particles, they will be apart and away from each other. Right? Now, take a look at how is it that the P wave moves, if at all it will move. So, if again the focus is somewhere here, again to tell you that energy will be released in all different directions. It is just an example that I'm indicating to you. So here, first this particle will vibrate. Now it will come into the area of the second particle, the region of the second particle. It will disturb the second particle as well. The second particle will also observe a kind of a variation and oscillation. The third particle will also observe a variation and oscillation. The fourth particle will also observe it. The fifth particle will also observe some disturbance. So even in the areas or the regions where the particles are slightly far away from each other, in them also, as the particle vibrates, it will disturb the space of the second particle. So the second particle will also vibrate. That will disturb the space of the third particle and it propagates. So because of this, due to this, the P waves are able to move through both gaseous and liquid mediums. Along with the solid also. Now let me ask you another question here. So in the solid, the particles will be very close. Liquids, the particles will be slightly farther away. Semi-solid somewhere in between. Gaseous completely away. Now, the closeness of the particle or the closeness in which the particles are packed, that is what we refer to as density. So when we talk about the speed of the wave will be greater where? When the particles are very dense or when you have liquid or gaseous state. When is it that the speed of the wave will be maximum? Very good. So, as dense as the particle gets, the speed of the wave also improves. So, the speed is directly proportional to the density of the medium. Okay? So, speed of the wave is directly proportional to density of medium. Okay? Now, Now let us take a look at S waves or secondary waves. How is it that the secondary waves behave? How focus start? What cause to act focus? Your question is not clear, my dear friend. What is it that you are trying to ask here? How focus is not starting, my dear friend. Focus. What is focus? Is there is focus understood? Is there any doubt in focus? What do we understand by focus? Let me know, Chandrasekhar. Then I will proceed further. What do you understand by focus? Center. Center for what? You said starting force. Okay. Understand this. Regardless of whatever I have said, regardless of whatever you have understood, erase everything from your mind. Understand a very simple aspect. Focus is the point of origin of earthquake. Wherever the earthquake will originate, that is referred to as focus. Now, where the earthquake originates, there will be release of massive amount of energy. So that energy will travel in the form of wave. So where will that energy originate from? Will that energy originate from the sun or will that energy originate from where the earthquake has occurred? Obviously, where the earthquake has occurred. So can we say that focus will be the point from where energy will be released? Is it something which is understood? Focus will be the point from where energy will be released. So that is the energy which is released. Now that energy travels in the form of waves. Different types of behavior of the particles are observed, but the energy travels in the form of the waves. That is what we have as the seismic waves. Yes, Somo, that is correct. So seismic waves travel fast in solid, correct. What caused to energy released? Okay. So, for all these cases, I would always suggest to you that in case you have missed out the initial portion of the discussion, kindly look at the recordings which are available. That is something which you can always revise. I have repeated this endlessly since yesterday that why energy is released, where energy is released, how energy is released. Let me repeat it for the 15th or the 20th time now. Whenever you have two crustal portions, two plate regions, two cracks, two rocks, where whatever you consider, whenever they will try to move against each other, Now the question, if that question is why do they try to move against each other? Because of the forces acting from the interior, the endogenic forces. They will always try to move against each other. So that is where, when they try to move against each other, the movement will never be smooth. The movement will always be rough. Is that understood? Is that understood, Chandrasekhar, that the movement is not going to be smooth? Movement is going to be very staggered. So here, when the movement is going to be staggered, the movement is going to be rough. So here, in that case, let's suppose I have my fingers representing here a kind of a rock. This movement that I'm doing is not a kind of a dance here. Try to understand the analogy of it. So if this is, let's say, representing a thick layer of rocks, this again is representing a thick layer of rocks. When they try to rub against each other, let's suppose these two fingers are the ones which express resistance against each other. What will happen? Apply your logic. One is trying to move in this direction, other is trying to move in this direction. There is a resistance which has happened. What do you think will happen at the end of it? What does your mind tell you? What do you think will lead would happen there? Basically, eventually, they will continue to apply the force, right? They will continue to apply the force till they overcome the resistance, maybe by breaking it, and they will suddenly move. So when they will suddenly move, why do they move? So I hope you have heard about this in the school days, that mechanical energy is of two types. You have the potential energy and you have the kinetic energy, right? I think you would have heard about these names. So when we talk about in the same place energy building up, that is your potential energy. And when the object moves, that releases kinetic energy, isn't it? So that energy which is released, that energy will shake up the surface, isn't it? So that is the energy which is released during an earthquake. Is that understood now? Let me know, Chandrasekhar. Is that understood, or is there still a doubt? If you have a doubt, feel free to ask. I'll repeat it once again if I'm repeating it. Okay? Okay. Can you please repeat the gaseous and the liquid part? Okay. So basically, and Syed, you had an issue about the movement of the P waves. So here, understand that when we have the P waves, in the P waves, the particles, they move in the same direction as the wave in itself is moving. So as the wave is initiated, the particle will disturb the next one, that will disturb the next one, that will move ahead. So in this manner, closer the particles, greater will be the speed, and closeness of the particles is something which decides which is decided by the density, or which is designated or represented by the density. So we can also say higher the density, greater will be the speed. And why is the speed high? Because the movement is happening in the same direction as the particles are moving. So in the case of liquid and gaseous medium, even though the particles, the molecules will be further away from each other, let's suppose the molecules are very far away and there is an energy which is released. This will shake it here. This will shake it. Now, when this particle is shaken, this particle space is somewhere which is disturbed. So when this particle enters the other one's space, the other one will also be disturbed. That will also start shaking. The third one will also start shaking, because eventually these particles are bound by a kind of a bond, a simple bond, right? So that is why even in liquid or gaseous medium, despite the fact that the particles are far away from each other, the P wave manages to travel through. But it will travel the fastest in the dense solid. It will travel the slowest in the least density area. So that is why speed is directly proportional to the density of the medium. Okay? I hope that is understood. Now, Now we come to the shear wave, the secondary wave, or the S wave. Now, it is also referred to as a shear wave or an S wave. Now, this is a wave which is emitted at the same, or this is the energy emitted at the same time, or the same energy that we are talking about, but the wave motion and the particle motion, that is something which is different. In this case, the particle motion and the wave motion, they are perpendicular to each other. How? Let us talk about that. So let's suppose we take the same case of the particles which are closely packed with respect to each other. And here is your focus. Now, when energy is released, nobody tells the particles that you have to move only in this direction because the energy is released. The particles tend to behave in different manner. So here, the particles, they get disturbed in this manner. The first particle will get a disturbance like this. The second particle, which is very much linked with the first particle, that will also get disturbed accordingly. The third one will also get disturbed. The fourth one will also get disturbed. And like that, the wave disturbance moves ahead. So this is the direction of wave movement. And overall, you will observe the wave to be generated like this. In the earlier one, the wave would be moving with the help of compression, expansion, rarefaction, etc. In this one, the wave would be moving somewhat like this. Where you have to understand, each of these particles, they are actually vibrating in this manner. Each of these particles, right? So, the direction of movement of particles is perpendicular to the direction of wave motion. So, direction of movement of particles is perpendicular. This figure represents, this symbol represents perpendicular to the direction of wave motion. Okay, that is how they are disturbed. If you have the query that why is it that in the first case the particles were moving in a certain manner, in the second case the particles are moving in a different manner, when the energy is released, particles will be disturbed in all sorts of manner. So that is how you have the energy which is transmitted. One energy is transmitted in the part in which the particles move in the direction of the wave, and that is the P wave. In another one, the particle starts disturbing or getting disturbed in a kind of a different manner, and that will disturb the other particle, and that is how the wave propagates. That is referred to as the S wave. Now, in this case, again apply your logic. The particle, first of all, will move vertically, suppose, and or any direction. That will disturb the second one, so the second one will move. That will disturb the third one will move. That will disturb the fourth one will vibrate. Now, in the case of the P or the S wave, we have seen in the case of the P wave, the direction of vibration in the case of the P wave is the same as the direction of the particle motion. In the case of the S wave, the direction of the particle motion is different. So where do you think the wave will be able to travel faster? When the direction of the particle and the wave movement are same, or when they are different? In which of them do you think the movement of wave will be faster? Always in the case of P waves, because in the P waves, the disturbance is transmitted faster. So that is why P waves are close to around 1.5 to 1.7 times faster in comparison to S waves. Always P waves are going to be faster in comparison to S waves. Okay. Now, here, let us consider the case of liquid and gaseous medium. Now, liquids and gaseous medium means the particles are actually far away from each other, right? Let's suppose this is where the focus is. Okay. Now, here, when you have the disturbance in the first particle which is felt, so let's say the first particle vibrates like this. Will the second particle which is far away also be disturbed in the same manner? Suppose the two particles are far away, one gets disturbed like this. Will the second one also get disturbed in the same proportion? Absolutely no, isn't it? So this is something where the disturbance will be very less, right? By the time we reach the third particle, the disturbance will be further less. By the time we reach the 10th particle, there will be no disturbance felt at all, isn't it? Had the particles moved in the same direction as the wave, they would have carried on the disturbance forever. But in this case, the disturbance actually mellows out, it dampens out because the particles are moving in a different direction altogether. So, this is the reason why S waves they never travel through or they are not able to move through liquid and gaseous medium. This is the reason why here S waves are unable to move through liquids and gaseous medium. Okay. Now, this is basically the characteristic. I'll tell you the question which has been asked from this particular area so that you get a context of it and then we will move ahead. I'll give you the question. Okay, which was asked this year, 2023. I'll write it down. So here you have consider the following statements. You have two statements which have been given. First is, we will discuss this question later. In a seismograph, P waves are detected earlier than S waves. Second statement is, in P waves, the individual particles vibrate to and fro in the direction of wave propagation, whereas in S waves, the particles vibrate up and down at right angles to the direction of wave propagation. Okay, so you had to select the correct statement. A, 1 only, B, 2 only, C, both 1 and 2, D, neither 1 nor 2. So, I hope you'll be able to take a look at this. I'll launch a poll for this. Let me know what do you think is the correct answer? Good. A great majority of you have given the correct answer. So the correct answer is C. And why is the correct answer C? First of all, P waves, they are able to travel at a faster pace, isn't it? Why? Because the particle motion is the same as the case of the wave motion. And the second statement here, when we talk about it, so there the individual particles move to and fro in the same direction as the wave propagation that we have seen in the P waves, whereas in the S waves, they move basically in a vertical manner and then the wave moves in a different direction. So that is why the answer will be both 1 and 2. Is it something that is found to be easy, or is it something that you found it tough, this question? Why does both P and S wave not happen at the same time? They happen at the same time. They originate at the same time. They travel with different speeds. Why? Because the way the particle behaves, that is different. Okay. To and fro. Okay, you don't know the meaning of to and fro. To and fro means something like this. To and fro. To and fro. So that is the meaning of it. Okay. So this is where directly from the PPT a question had been asked. That is why I would urge all of you to please, and again in climatology, again I will tell you directly from the PPT a question which had been asked. So questions are not something that UPSC fetches out from the moon. There will be a couple of questions like that. But if you stick to the basics, if you understand the basics, and if the basics are in place, then you won't find an issue whatsoever. A very quick recap I will give you is that when we talk about the body waves, these are the waves which travel through the body of the earth. That is why they are referred to as body waves. Now, in the region of where is it that the energy is transmitted or originated from? In the region of the focus. Now, when the energy is transmitted or the energy is emitted, initially, when we talk about the particles behave in a different manner to the energy which is released. Now, in one kind of wave motion, the particles, they will start vibrating to and fro or in the same place, in the same direction, and the wave will get transmitted further ahead. And that is one of the fastest methods of wave propagation, isn't it? When let's say you have 10 people standing in line, one people hitting the next one, that one hitting the next one, immediately the first person on the line will also get hit. You would have observed it in a queue. Many of the times you stand in a queue, isn't it? Railway stations, movie halls, anywhere where you have stood in a queue. If there is a last person which has pushed you, someone, regardless of how far you are standing from that person, you will also experience a push, because everybody in the line experiences a push. But if the last person vibrates like this and then starts to vibrate the next person, by the time that vibration will reach to your end, you might have moved away, isn't it? So same is the analogy in the case of P and S waves as well. In the case of the P waves, the direction of the wave particle and the direction of the wave movement in itself both are similar. So that is how, just like in the case of sound waves, how the sound wave moves, that is how this wave also ends up moving. So even when the particles are slightly far away from each other, there also you will have a kind of a motion And that is why the P waves, they are able to travel through liquids and gases as well. But when we talk about the S waves, here if let's suppose the wave motion is it to happen in this direction, it will happen by the particle getting disturbed like this. That will disturb the second one. That is going to disturb the third one. So by the time that you reach the fourth one, already the particle motion is slower. So that is why S waves are slower. And in case when the particles are far apart, like in liquids or gases, the wave in itself dies down by the time that you reach the fourth or the 10th particle. That is why S waves are unable to travel in any medium other than solid. So in liquid and gaseous mediums, S waves are not able to travel. So that means P waves are faster, isn't it? That means P waves move at a faster pace, right? So if you have the surface and here you have the focus, which wave will reach first? P wave. Then it will be followed by the S wave. That is why majority of the early warning systems that you have for measuring or creating a warning signal for an earthquake to strike, all of them, they work on the same basic principle. They are able to detect the P waves, and whenever they are able to detect the P waves, immediately the alarm is sounded, and immediately everyone, because there's a gap of close to around 1 minute or half a minute, or maybe 2 minutes, 3 minutes between the P wave and the other combined forces of the other different types of body waves which strike the surface, because there are multiple different body waves. P and S are the only two that we are covering because these are the only two relevant for your general studies. But there are multiple different types and categories of body waves. So the P wave that moves first, that shakes the surface, and then the slower waves they come and they provide the actual shaking, the actual earthquake, which generates the surface waves, which gets transmitted outwards. Okay, is that understood? Pooja, body wave not understood. Which part of body wave is not understood, my dear friend? Is it like the entirety of the portion has gone above the head, or some portion of body wave is not understood? Because it is like after the entirety of the story has come to an end, entirety of Ramayana, you said that who was Sita. It is like that. So, which part of body wave is not understood? S waves do not travel in asthenosphere. They will travel in asthenosphere. They will not travel in outer core, Kambapati, because asthenosphere is semi-solid. Why earthquake is unpredictable? Because how do we predict where the earth, where the land is going to move, or when the land is going to move? How do we predict that? Then, Shanmuga Priya, if the particles are far away from each other, will the wave travel slower? Yes, absolutely yes. After major earthquake, we often have minor earthquake. These are like, yes, correct, Sayyid. They are going for the final adjustment. Satyapal, the first point. First point of what, my dear friend? So, the question, observe the question. In seismographs, P waves are detected earlier than S waves. So, why is that? If that is the case, why is that? That is because P waves travel at a faster speed. So, obviously, seismograph will detect P waves first, isn't it? Right? Shalja, everybody gave the correct answer in the first one, so there's no point of showing the leaderboard. And okay, seismic waves. What are seismic waves, you are asking? Seismic waves are basically the energy waves which are emitted whenever an earthquake strikes. How earthquakes are possible below the lithosphere? Because the crustal movement continues, or rather, the plate movement sometimes continues even underneath the asthenosphere. Okay? The liquid and gaseous means that they are present underneath. They can be present anywhere. They are present when we talk about the structure of the planet. Liquid is present in the outer core. Gaseous, where it is present, we'll talk about it. Okay. Vivek, the second statement. Have you read the second statement? What is it that you have not understood? Let me know. Patel, why has Gujarat not experienced too much? What are you saying, Patel? Gujarat is one of those areas which is massively ravaged by earthquakes. In case you don't remember, or in case you were too young, ask your older generation about what happened on 26th of January 2001. You will get an adequate answer. Okay. So, for all of you, I want you to talk about, or whenever you are raising any doubt, please don't have a kind of a larger that explain everything. Find the doubt, precise point that you have not understood. Ask that, I will explain that. Individual particles here refers to the molecules. Okay, let's take a break now and let's be back after the break. So, we take a break, 15 minutes, and we come back and we continue. All of you happen to S waves, the particles vibrate up and down at right angles. Because if you observe the image that we have depicted here, observe what is the direction in which the wave is moving. Whichever direction the wave is moving, here, it is the other particle movement is actually perpendicular to the direction of wave motion, isn't it? So that is why the overall speed of the wave also ends up reducing quite sufficiently. Okay. Does the P and S wave earthquake happen intense immediately or require time? So whenever an earthquake happens, both P, S, P star S, P, G, S, G, all the various different types of body waves are emitted at the same time. Okay. Difference between Mercalli scale and Richter scale. Mercalli scale basically ends up measuring the amount of damage that is caused in terms of, so you classify an earthquake based upon the amount of damage. For example, let's suppose an earthquake has occurred where you have felt the earthquake. The buildings have not shaken actually, but you have felt the earthquake, the objects have moved. So that will be of a different scale. An earthquake which has occurred where all the buildings have been destroyed, that is a different scale. So in any of these, you are not measuring the energy released in an earthquake. So that is done by Mercalli scale. When you measure the energy, that is where the Richter scale comes into play. Okay. Full form of P waves is primary waves, my dear friend. And Divya, where are Richter scale placed or located to measure the magnitude of an earthquake? So basically, these Richter scales, these seismographs rather, it is not the Richter scale which is placed, it is actually the seismograph which is placed. So seismographs are placed across observatories spread across the planet. You have many various different vessels, ships, etc., which also place a seismograph in order to measure an earthquake happening even in the remotest of the location. So, when an earthquake occurs, we have seen that the body waves end up traveling and getting transmitted throughout the planet. So, if let's suppose this is the planet, an earthquake has struck here with this as the focus. The body waves will be transmitted in all the various different directions. In all the different directions, the body waves will get transmitted. So if you have a seismograph installed here, if you have a seismograph installed here, here, and so on, so all of them will be recording these body waves. Even if there is the slightest of record, it will record that. And by triangulating and collating the data of all of this, you are able to triangulate where is it that the focus has been situated, what is it that the energy has been released. That is why when you will observe, let's say you would have observed that whenever an earthquake occurs even in India, immediately you will observe that if you will notice that even the US government releases a data about the details of the earthquake. How is it that they know about it? based upon the series of seismographs that they have placed across the planet. So that is how we get an idea. Okay. S waves, they are unable to travel through liquid and gaseous mediums because in the liquid and gaseous mediums, the particles are placed very far away from each other. And in the case of the S waves, let's suppose the particles being placed far away from each other, one particle vibrates like this. It will not induce a vibration in the similar manner in the second particle. So that is why the S waves, they end up dying out. Okay. Where and how to use the earthquakes instrument to study the earthquakes? As in, if you, Chandrasekhar, if you are asking where to place the seismographs are placed across the entirety of the planet. All of them, they end up measuring the slightest variation in terms of the vibration that the surface experiences. All of that is recorded in the seismograph. S and P waves, Nazarkar, they are generated at the same time. They are received at different time due to different speed. Tomorrow class will be at around 9:30. Okay? No, Richter scale and Mercalli scale, they are not a part of seismograph. They are basically, they are used as a scale of representation to classify which kind of earthquake it is. Yes, 7:30 to 11. So you would have received the detail about it. So it is 7:30 in the morning. Okay, the class will be at 7:30 in the morning. Right? Yes, Lakshya, that is correct. Surinder, you don't have the geography class for tomorrow. Tomorrow you will have the extra session for the history class. Okay. Now, can we move ahead? Is there any reason for sudden earthquake in Gujarat? So yesterday we had talked about it, that why Gujarat receives earthquakes, and that is because Gujarat lies at the boundary of three different plates. You have the Arabian plate, you have the Indian plate, and you have the Eurasian plate. So any respective movement or relative movement happening across any of these plates will have an impact on the region of Gujarat. That is why Gujarat experiences earthquakes. Okay, right? Okay. Now, here the difference between P and S waves. So P waves are the first waves to hit the Earth's surface. Why? Because they travel at a much faster speed. So the P waves, they travel generally at a speed of around 4.5 to 13 kilometer per second. And because they end up hitting the surface first, that is why you will observe that majority of the early warning equipments that you have, the early warning equipments in terms of alarming people that the earthquake is about to strike, majority of these instruments are actually placed and located in the, or they are the ones who are actually going to measure the P wave vibrations. So immediately as the P waves are detected, that alarm signal goes on, and that is where people get an idea that an earthquake is going to strike. Japan is one of those countries which has implemented this on the large scale, because if you take a look at the region of Japan, Japan is very active seismically. Why? Because it is the region where Pacific plate is undergoing subduction underneath the region of the Eurasian plate. That is why Japan also experiences frequent volcanic eruptions as well as seismic activities. Now, in the region of Japan, you also have the high speed train network, the high speed rail, the bullet trains. Now, there was one of these incidents of earthquake events which happened where, due to the shaking of the earth's surface, these high speed trains, they got derailed and a lot of lives were lost. There were huge amount of casualties. Now, since that point of time, what Japan has done, it has installed those P wave detectors across the high speed linkage and across the general buildings as well. Immediately when an earthquake strikes, first of all the P waves will reach, the alarm is triggered, and wherever the trains are, regardless of the speed at which the trains are operating, immediately they come to a stop, immediately they come to a halt, and that is how lives are saved. So this is how you can manage these disasters. Okay. Now, after this, here P waves, they travel in a kind of a linear direction. The direction of the movement of the wave is with the help of compression and rarefaction of materials. Compression and rarefaction of materials. That is how the waves will end up getting transmitted. Whereas in the case of S waves, we have seen it is a kind of a transversal direction. So P waves, they travel very similar to the movement of the sound waves. So the movement is very similar to sound waves. And in this case of S waves, movement is similar to the behavior of light waves. Okay? Now, these waves, the P waves, can travel through solid, liquid, and gases as well, whereas the S waves, they end up traveling only through the solids. So these are your body waves because they end up traveling only through the body and the internal structure of the planet. So that is why they are referred to as body waves. Now, once these body waves, they will hit the surface, they will disturb the surface. The surface, wherever it is, once these waves they hit the surface will be disturbed, and there will be a generation of a wave like pattern on the surface as well. This portion will get disturbed, that portion associated with the main one, and so on. That will also get transmitted. So that is what we refer to as the surface waves. So surface waves, they are put into motion once the body waves hit the surface. They hit the epicenter, and then the surface waves are triggered. So they are triggered once the body waves hit the epicenter. Okay. Now, these waves cause maximum amount of damage because in the case of P or S waves, it is only the epicenter which gets shaken up. It is the epicenter which can be raised up or moved sideways. But then when you talk about the surface waves, if let's say the epicenter starts moving sideways, also gets disturbed upwards, both these motions are transmitted into the land area, and the land behaves in a different manner. The land starts shaking up. The land can also end up developing a kind of a wave like pattern like this, or can end up vibrating in a horizontal manner. So that can always happen. So surface waves are those waves that travel on the surface. The destruction is primarily done by these particular waves. Now here, it, even though it is not required for your general studies significantly, but just to give you an idea that the surface waves can further be subclassified depending upon how is it that the ground is shaken, or how is it that the ground is disturbed. And accordingly, you have the L and the R waves, or the love waves and the Rayleigh waves. So when we talk about the overall speed comparison, P waves are going to be the fastest in terms of how do they move, in the terms of the time that they take to move from one region to another, followed by S waves, that is to be followed by the love waves, and then you have the R waves, which will follow, or Rayleigh waves. Just to indicate to you that what kind of shaking is observed in the case of the love waves, you will observe that when you have the love wave striking, it is the horizontal shaking of the earth's surface. So if let's suppose you have a building on top, now as this moves in a horizontal manner, the building will also get disturbed. If it has got a kind of a Rayleigh wave characteristic, the building will also come up and down. It is when both of them will act in unison, both of them will act together, that is where all the buildings will tumble down if the wave is very powerful. So that is your seismic waves overall, classified into body and the surface waves. Okay. Now, After this, we come to the concept of shadow zones. So, when we say shadow zones, here, in order to understand this, first of all, let us associate with a basic concept of how is it that the waves will move. And when we talk about the body waves, we have already seen it multiple times that the body waves will end up getting transmitted throughout the body of the planet. Throughout the internal region of the body, the waves will get transmitted. Now, if I ask you one question based upon the Earth's interior, we all have studied the Earth's interior and the Earth's structure. So, if I ask you a question here, let's suppose we consider this to be the Earth's interior. Now, let's suppose we consider the various layers of Earth. Now, first question that I'll ask you, that if let's suppose the focus is somewhere here. Now, we know that the body waves will travel throughout the internal structure of the planet. But when they will travel through the entire structure of the planet, will they be encountering materials of the same density, or will they be encountering materials of different densities as they travel? Different densities? Very good. So, as the body waves will travel, they will be encountering materials of different densities. Now, when energy waves they travel or they interact with materials of different densities, do they continue to stay in a straight path, or does their path get diverted? What do you think? When the energy waves they travel or interact through materials of different densities, will they be traveling in the same path, or will their path get diverted? They will get diverted, isn't it? You would have read about refraction in general. You would have read about the term refraction in maybe your class 9th or your class 10th standard, where you would have studied that if you have a glass, as light strikes that glass, that there is a kind of a bending which happens as the light moves through from air to glass and again from glass to air. So what does that mean? That means we can basically have a conclusion associated here. What is the conclusion? That energy waves, when moving through different mediums, will bend or get deviated. Right? Can we say that? That energy waves, when they move through different mediums, they will get bent or they will get diverted. Similarly, when you have these body waves, these are the ones which will reach the Earth's surface immediately in the region of epicenter. Let's suppose here you have the focus. Let's suppose here is where you have the epicenter. Okay. Let us suppose here is where we have the epicenter. Now, as the waves they will get transmitted through the rest of the portion, they will entering materials of different densities consistently. Let me use a different coloration pattern here. So consistently, they will be encountering materials of different densities. So all of them will bend. Now, when they are bending, again, apply your logic. Can there be a possibility that few areas of the planet will be the ones where these waves will never reach because all the waves are bending? Can there be a possibility of certain areas which never get exposed or which will never receive these waves? Right? Perfect. So those regions which do not end up experiencing these seismic waves, if an earthquake, let's say, has struck somewhere, those regions which do not experience those seismic waves, they are referred to as the shadow zone of the earthquake. So, for example, here when we take a look at the shadow zone, you have two different shadow zones. This is what is your P wave shadow zone, the first one, and this is what is your S wave shadow zone. Understand each one of them individually. Let us start with the S wave first. Now, here is where the focus has been. This is where the energy has been released, and this is where the energy has originated. Now, once the energy gets originated here, observe it will bend in all directions. It is bending in all directions. Observe the region of core. Now, outer core is in what state? Outer core is in liquid state. And in liquid state, S waves, they cannot travel in liquid and gaseous state. So the S waves will be completely absent in this region, even though the inner core is in solid state. The inner portion of the core is very much in solid state. But in order to travel through inner core, first of all, you have to reach the inner core. And in this case, can they be able to reach the inner core? Absolutely not. So that is why in this entirety of the region, no direct S waves will be received. Isn't it? No direct S waves will be received here. Why? Because the S waves, they are, excuse me, because the S waves, they are unable to travel through the liquid medium. So as soon as the outer core comes in any area, they won't be able to travel. So this is the shadow zone, right? So the shadow zone, from the region where the earthquake has occurred, shadow zone extends up till around 105 degrees or 103 degrees. On either side, there will be no direct S waves experienced. What about the P waves? P waves can pass through liquid, P waves can pass through gases, P waves can pass through solids. So as these P waves are emitted, observe these P waves here. They will encounter material of different density. They will move through the region of the outer core as well, and they will be moving through the region of inner core as well. However, because of bending, there will still be certain area at an angle of 105 to 145 degree on both sides of the focus, where due to bending, no P waves are received. So that will be the shadow zone for the P waves. So it is by studying these P and S waves, because we know the property of P and S waves now. We know the property of various different materials. So by recording the movement of these P or S waves with the help of the seismographs, when do we receive them? Where is it that the focus is? How much time does the wave take to reach here? By that, can we be able to calculate what is present in the interior of the planet? Will we be able to decipher what are the different types of minerals present in the interior? Will we be able to decipher which is the state of matter which is present in the interior? Isn't it? So that is why seismic waves are referred to as one of the most important indirect sources when it comes to information about the interior of the planet. This is used to understand not only about the interior, but also at what rate is the interior, let's say, changing a state, where it is semi-solid, semi-liquid, etc. Now, both these ways will be able to travel through asthenosphere, because asthenosphere is not a complete liquid. It is a semi-solid or a semi-molten plasticky state that it is in. Okay, so that is what you have as the shadow zone. And just so that you don't get confused, let me tell you that even if, let's suppose, this is the planet, let's suppose the earthquake has struck here. Let's suppose. Now, here also, the waves will be moving in all different directions. And there also the bending will happen based upon the materials of different densities that they encounter. So here also for the S waves, the shadow zone will extend from 105 or 103 degree from both sides. This will be your S wave shadow zone. Whereas for the P waves, the shadow zone will exist only for this small area. Why? Because the P waves are able to travel through the region of the core, and not only travel through the region of the core, when they reach the region of inner core, which is in very hard and solid state, that is where the speed also ends up increasing. This is the observation which was carried out by Lehman. And Lehman, for the first time, observed and noticed that the speed of the P waves are increasing as they are passing through the region of the core. That is the reason why the discontinuity between the outer and the inner core is referred to as Lehman discontinuity, because he was the individual who basically came upon the conclusion that there must be a solid inside the core where the P waves are increasing their speed. So that is where the Lehman discontinuity comes from. So this concept of shadow zone is created, or is the one which helps us understand not only about the interior, it also helps us understand about the types of minerals present, their distribution, their concentration. All of this is understood in detail. In fact, it is also by studying of these seismic waves by which many of the times even the countries get to know whether you are carrying out an explosion in your country or whether there is a nuclear explosion being carried out, because you all would have or you would be aware of the fact that, let's say, when India carried out that nuclear explosion now in Pokhran, immediately after that, all the countries came to know about it. The press statement was released almost a couple of hours later, but by that point of time, all the countries of the world knew about it. How? Because even when you carry out such a powerful explosion like a nuclear explosion, that will also release energy which will travel through the body. And the seismograph, that indicates the difference, because in a seismograph, when you talk about the normal wave, the normal earthquake wave, they will always have some foreshocks, some amount of aftershocks, right? But if it is the shaking is carried out by a nuclear explosion, it will show a very concentrated peak, and then again peaceful after that. So this tells you this is something artificial and not natural. Okay. uh why we have shadow zone in the case of P waves? Because the P waves, okay, first of all, tell me that, will do all of us agree on the fact that the waves will bend as they travel? Do all of us agree to that, or do we have any doubt later? Any doubt in this? We all agree to this, that the waves will bend, isn't it? Now, when the waves will bend, so obviously there will be certain areas where the waves will not be able to reach. If the wave is to be reach here, it has to bend accordingly to reach here. But here, as soon as it encounters a liquid outer core, so there again there will be some amount of bending, because the density of the liquid outer core will be different, and then it will be bending like this. Here, the ones which encounter the solid inner core, there the speed will speeden up significantly. But here, the bending will continue nonetheless. Here also in the S waves also you observe bending. So due to that bending, there will be certain area which will not experience the waves, which will be bereft of that waves at all, completely. So that is why they are referred to as the shadow zones. Is that understood? Good. Sir, you mean P wave shadow act at a time of to and fro of the earth? At a time of to and fro of earth? Your question is not clear, Chandrasekhar. Will P wave of an earthquake of very less magnitude be able to reach across the planet? Yes. Even the slightest of disturbance, which will be recorded only by the seismograph, but it will reach. Okay, right? What is the query? See, I have devolved more than around 40 minutes for doubt clearing. How will we proceed like this? Do S waves start by the side of the focus or above or below the point? At the point of focus, Kalpesh. And is it possible that a seismograph placed by America in their territories, they end to know the center is in the epicenter is in India? Yes, because eventually the waves will travel, and it is not as if they will be relying on the seismographs only in their country. They have placed seismographs even in the oceans, even in various different areas. Various different agencies coordinate with each other when it comes to sharing of data for this matter. In shadow zones, earthquakes can happen. Absolutely, yes. Okay. Only in P waves when waves won't travel. That's known as shadow waves. There is nothing as shadow waves. There is something referred to as shadow zones. So shadow zones. So when an earthquake, let me write it down so that you get some satisfaction. When an earthquake occurs, body waves travel through. All these definitions are there, which are present in the additional reading material, guys. Kindly refer to them. Kindly refer to them. Kindly study them. Body waves travel through the interior of the planet as they encounter materials of different density. They bend accordingly. Okay? There are certain regions which do not experience these waves. They are known as shadow zones. Is that understood? Why all this apply rule apply to all regions across the circumference? Yes. There is nothing as layman concept. What I was trying to tell you is that as the P wave moves through the region of the outer core, eventually through the region of the inner core, its speed suddenly increases. And this is something which was observed by layman first of all. And that is why layman noticed that, and he came to a conclusion that there must be a very dense solid particle present in the region of the inner core, which is increasing the speed. And that is where he come upon the conclusion of a solid inner core. And that is why the outer and the inner core discontinuity is referred to as the Lehman discontinuity. Okay. How one line is able to pass straight here? Okay, please understand, these are artistic recreations. These are not the recreations of the planet Earth and someone actually drawing out these waves. In reality, there will be significant amount of distortion. So all of you who are basing the entire aspect based upon this artistic recreation, this is to help you understand the larger perspective. Don't ratify the exact line and the exact direction that the line takes. Just keep in mind that for the P waves, the shadow zone exists between 105 to 145 degrees on both sides, whereas for the S waves, the shadow zone is 105 from both sides. So that is why shadow zone created by the S wave is much larger than the shadow zone created by the P waves. Shadow zone created by S wave is much larger. Again, again, I will reiterate this point so that you don't get confused. An earthquake can occur here. If an earthquake occurs here, shadow zone will be somewhere from here to here, 105 degrees. When we talk about that, is from the point of focus. Okay, it is from the point of focus that you are calculating that 105 degrees. It is not as if these regions will never experience an earthquake. So earthquake can strike anywhere, any of these. Wherever it will strike, the shadow zone will be at that particular angle associated with the focus. Okay, is that understood? Means earthquakes happened on west and east poles. Means earthquakes happen on west and east poles, means suppose it happens in the west side of the earth and this shadow cause. Okay, so I understand where the query is. So basically, if your query is that an earthquake has struck here, will the person here experience the earthquake or not? That is the query many of you have, right? Chandrasekhar included, all of you have the same query, that if an earthquake strikes here, will the person here experience an earthquake or not? Isn't it? So that person will not even feel the earthquake. To be more precise, even an individual placed here, he will also not feel an earthquake. An individual placed, let's say here, they will not experience an earthquake. It will only be recorded with the help of seismographs. Only with the help of instruments will you be able to detect those minute and very tiny variations of energy which is coming in. So if an earthquake occurs in Nepal, do you think that people in United States they get disturbed by that? Absolutely not. If an earthquake occurs in Alaska, do we in India experience that? We don't. When an earthquake occurs in, let alone Alaska and region of Afghanistan, do people below the Tropic of Cancer or do the states below the Tropic of Cancer ever experience an earthquake? No. So even when the earthquake happened in Gujarat, did people of West Bengal experience that earthquake? No. So it is not about whether you experience that earthquake on your own or not. It is the instruments which will detect them. Okay. Is that understood? Why do shadow zone experience earthquake? Earthquake can happen anywhere, my dear friend. Shadow zone, what is a shadow zone? Shadows, when an earthquake occurs, the seismic waves, when they, and listen to this carefully before copy pasting the same question again and again, all of you. Listen to what I'm trying to say very carefully. So, shadow zone is created when you have an earthquake which occurs and the energy waves or the seismic waves which are transmitted, they are unable to reach all the places of the planet. So, they are referred to as shadow zones. P waves will also not be able to reach the entirety of the planet. S waves will also not be able to reach the entirety of the planet. So, both the P and the S waves, they will have their own distinct shadow zone. Earthquake can occur anywhere across the planet. For every earthquake, it will have its own distinct shadow zone which will be created. Okay? Does not mean that in a shadow zone an earthquake cannot occur. Earthquake is what? Shaking of the earth's surface. So that can happen because of various different reasons. Once that earthquake occurs, then the shadow zones are created. Is that now understood? Tarun, you had a question that you repeated multiple times. Why do shadow zone experience earthquake? Why won't the shadow zone experience earthquake? When P wave can travel through all the medium, then why shadows? Shadow zone is created in the P waves because the P waves, they will get bent as they encounter materials of different density. The P waves, they bend up. So, anywhere when you have a spherical object, the materials or the waves, when they get bent, there will be certain areas where they won't be able to cover it up. So, that is why you have the shadow zone which is getting created by the P waves. Pavitra, you have repeated the same question. Is that understood? Can it happen like there is no shadow zone? No, there will be a shadow zone. There will always be a shadow zone at an angle of 105 to 145 degree in the case of P waves from focus, and at an angle of 105 from both sides from focus in the case of S waves. Okay. Now we come ahead to the portion of the earthquakes when they generate. Why S waves cannot bend? My dear friend, where is it? Is it not that you observe that even the S waves are bending here? Are you able to observe this or not, Sandeep? Please clarify. Are you able to observe the bending of these waves or not? If not, please tell me. So you are able to observe the bending. So where does that question come from that why S waves cannot bend? So please try to pay attention. Please don't suddenly wake up and paste the same question. Try to understand it. I have not taken your individual names, but majority of the questions that you have asked, I have replied to you that understand why these shadow zones are created, because the waves, they will never be traveling in the same line. Why? Because the energy waves, when they are moving through different medium, they will bend, they will get diverted, right? Now, after this, we move ahead with the portion of tsunamis. Tsunamis are basically something of, it is a kind of a Japanese term which refers to the creation and the formation of a giant wave, right? That is what we refer to as a tsunami. So, whenever you hear about the term tsunami, it simply represents a very giant wave. Now, these tsunamis are instigated primarily by earthquakes. There can be other reasons as well, but the prime factor for instigation of these tsunamis is the earthquakes. Now, if I ask you a question before that, for example, let's suppose we have the continental area here, and here you have the water body. Let's suppose we have the ocean here. Now, here, on the case of the land area, it is easy to say that this is going to be the surface. Okay. And that is easy to understand. But when we talk about the water body, if I ask you, out of places A and place B, which of them do you think represents the surface of Earth in this case? Beautiful. It is going to be B. This represents the surface. So if this surface is disturbed, let's suppose there has been an earthquake here, and this earthquake has disturbed the surface, that is the sea floor or the ocean floor. What will happen? Now that water will be disturbed. So from here, you will have a kind of a large wave which will get transmitted outwards just like ripples. And that is when they reach the coastline, they take the form of a very large wave causing a tsunami. Just like take the case of an example of a mug or a jar that you have at your house. Now, without disturbing the top, let's suppose if you provide a kind of a sudden force to the bottom of the jar or bottom of the glass, what will happen? The top will get disturbed or not? Obviously, yes. If the bottom is disturbed, the top will also be disturbed. So, similarly, when you have earthquakes happening underwater, where the focus is underwater or in the coastal area, it disturbs the surface, and that ends up disturbing the entire water column above it. And that is what initiates the formation of a tsunami. So, when we talk about a tsunami and occurrence of a tsunami, tsunami is basically Japanese for a giant wave. Okay. Now, this is generated generally when the focus of the earthquake lies under the ocean floor. Example, you have multiple such events. For example, take the case of December 26, 2004, tsunami which struck the Indian Ocean. And that was an earthquake which was a massive earthquake of a magnitude close to around 8, which struck the Sumatran coastline. And that created a tsunami which was so intense that it ended up ravaging and destroying the region of Sri Lanka, Maldives, eastern coast of India, Andaman Nicobar Islands, and many other regions of South Asia in general. Then again, 11th of March 2011. That is again when a tsunami struck across the coastline of Japan because of massive earthquake close to 8 magnitude, 7.5 magnitude, which struck the Japanese coastline. As recent as last year, when you had a very massive volcanic eruption on 15th of January 2022, a massive volcanic eruption, one of the most massive volcanic eruptions that we have observed in the current century, that is in the 21st century. It is the most massive volcanic eruption. So that volcanic eruption struck the island nation of Tonga in South Pacific, and that generated a tsunami which traveled across the Pacific and actually claimed the lives of two individuals at the coast of South America in Ecuador. So that is where these tsunamis are generally generated by the shaking of the earth's surface, which is mostly created by the earthquakes. Okay, I hope that is understood. Now, then after that, we come across the geographical distribution of earthquakes, which is going to be relevant for your mains examination quite significantly. When blast a bomb at bottom of the ocean, can we create an artificial tsunami? Yes. So if you take a look at the Cold War era, United States did carry out nuclear explosions, experimental nuclear explosions, which would always end up creating a kind of a mini tsunami. Why it not acted on both opposite sides of the earth? What is the reason? Means focus force not travel too long, right? Right, correct. So when what represents the artificial waves in seismograph, Akansha? So, artificial waves, when let's say you have, it is not the natural movement of the rocks which have created a foreshock, the main shock, and the aftershock. That is where you have the natural wave representation on the seismograph. When it is carried out, let's say, by an atomic bomb, a nuclear explosion, you will have just one kind of movement. That is it. Now, here, when we talk about the geographical distribution of earthquakes, so earthquakes, they do occur across various parts of the planet, but mostly they will be concentrated around certain areas. And those are the areas where you find the frequent plate boundaries. Because yesterday we have studied that how wherever you have the presence of plate boundaries, there can be an earthquake which can be experienced in that area, isn't it? So here, what kind of plate boundaries can have earthquake? Convergent, transform, and divergent. Convergent and transform will have strong and massive and high magnitude earthquakes, whereas divergent will have low magnitude earthquakes. So, when we talk about the earthquakes, distribution of earthquakes, mostly across plate boundaries. So here, convergent and transform, high magnitude earthquake. Why high magnitude earthquake in these cases? Because the land is moving against each other. There will be a significant amount of resistance which will be experienced. That is why very high magnitude earthquake. Whereas when we talk about divergent boundaries, it will have low magnitude. And why low magnitude? Because there the land is already trying to move away. There is not much of a resistance. So why the earthquake will occur at all? So when there is the land which is trying to move away, molten materials will try to come up. But the movement of these molten materials will not be smooth at all. These molten materials will also end up pushing through the surface. So that will end up shaking the surface ever so slightly. Across the globe, you will observe two different zones that are very prominently impacted by the earthquakes. One is the Circum-Pacific earthquake belt, which we also studied as the Pacific Ring of Fire. Why is it that this is very prominently influenced by earthquakes? Because in that entire zone, some or the other kind of convergence is taking place. And then you have the Mediterranean Asia earthquake belt. Now, again, this is an area where the plate movement is quite significant. So that is where you have these two areas which are designated as the prominent earthquake zonation. So observe this particular image. In this image, you will find the presence of the plate boundaries as well, or depiction of the plates as well, along with the regions where the earthquakes have occurred. So one is the Pacific Ring of Fire that you observe. Here you have the Nazca plate. The South American plate is colliding into the region of Nazca plate. Observe how great frequency of, or what is the high amount of frequency when it comes to earthquake. Similarly, here Pacific plate is subducting underneath the minor Amur plate, the eastward portion of Eurasian plate, that is a minor subportion. So there also you have very high frequency. So this is the region where Japan experiences earthquakes. Same is the case in the entirety of the area if you observe here, right? Now this is where you have the Tonga eruption which happened. Then observe the Mediterranean Himalayan belt. In this entire area also there is very high frequency of earthquakes. Why? Because slowly and steadily the African plate, as it is splitting into two from this particular region, the one portion of it is moving northwards into Europe. So in the next near-term future, you will observe the Mediterranean Sea disappearing from that region and the African plate colliding into the Eurasian plate, creating a Himalaya-like feature. So that is again where convergence is happening. So here also, you will experience very high frequency of earthquake. Other than that, earthquakes are also to be observed across divergent plate boundaries. Why? Because in the case of the divergent plate boundaries, consider the mid-Atlantic ridge for that example here. If you consider the mid-Atlantic ridge, now that mid-Atlantic ridge is where you have volcanic eruptions happening. Molten materials are coming up. But those molten materials, any kind of resistance that they will face, they will end up pushing against the Earth's surface, creating a force, creating an earthquake as well. Okay? So, a question whenever it is asked that which are the regions dominated by earthquake, you have to indicate the world map, a rough world map. You have to indicate the zones. You have to talk about it, that why various areas experience an earthquake. You have to talk about it, why Pacific Ring of Fire experiences an earthquake, why Mediterranean Himalayan region experiences an earthquake, why Mid-Atlantic Ridge experiences an earthquake, and that will be more than sufficient. Okay. Now, if you take a look at it, and it is not a mere coincidence that these are also the areas which are very prominently frequented by volcanic eruptions as well. And these volcanic eruptions also indicate the presence of plate boundaries. So wherever you have the convergence, significant amount of convergences, they will always end up initiating both volcanic as well as earthquake events. However, whenever you have only continental convergence, no volcanic eruption will be observed. Whenever an oceanic plate is involved, volcanic eruption will always be involved. Okay? Now, after this, the earthquake zones of India. So in India also, different zones have got varying probability in terms of their exposure to earthquakes. And they have the probability in terms of where is it that maximum compression of rocks have happened. So wherever there has been a greater compression of rocks, chances are that the earthquake can strike in that area. So in India, overall, you will see that the zonation is done from zone 2 to zone 5. It is not done from zone 1 to zone 5. And that is a learning that we have taken ever since the Koyana earthquake, ever since the Latur earthquake, because these have occurred in areas where nobody was expecting them to happen. Because largely the conception has been that, look, it is in the region of Himalayas where there is convergence which is happening. It is in the region of Gujarat where you have the boundary of three different plates. So these would be the regions which would experience earthquake. The rest of the area, the peninsula plateau of India, etc., they would be comparatively safer. But when the Latur earthquake happened in Maharashtra, upon further investigation, it was found out that indeed there did exist a kind of a crack in the earth's crust in the region of Maharashtra around Latur, and there a movement had happened leading to an earthquake. Now, what does that mean? That if you classify an area as zone 1, that means there is absolutely a negligible probability of an earthquake happening there. So that is why you have the zonation done from zone 2 to zone 5. The very prominent areas where you experience or where you will be expecting very high magnitude, high intensity earthquakes are the Himalayan regions, which are included in zone 4 or zone 5. These are the areas included in zone 5 and zone 4. Okay, so these are where you have very high probability of earthquakes happening in this region. And that is because there is a significant amount of folding, development of faults, cracks, etc. Now, if you can observe the entirety of northeastern states, they have been included in zone 5 because the amount of compression of the rocks which is happening in that region is much higher. So that is why there is a greater chance of the rocks coming back to their original position, leading to a massive earthquake. So that is why these are the areas where the earthquake can always be predicted in the future. It is in fact said that the rocks present in the region of the entirety of the Himalayan formation, the amount of compression or deformation that they have undergone, the amount of tension which is trapped there, in the next 100 years, we can expect at least 7 to 8 massive earthquakes to be occurring in that area for the rocks to gain a kind of a stability. That is why always the geologists will prescribe never to go for a large scale construction, let's say of a large dam or so on, in those Himalayan reaches, because it can, if the earthquake strikes and if that dam breaks, it will have a destruction potential which we cannot even imagine. Okay, so that is about the zonation. Now, then we come to induced seismicity or the earthquakes caused due to human actions. That is, yes, like Tehri Dam. So that induced seismicity is what? So human actions also end up instigating shaking of the Earth's surface. And that is what is referred to as anthropogenically caused earthquakes or human induced earthquakes. So various different events, they can also trigger the slight shaking of the Earth's surface. So for example, when we go for hydrocarbon extraction, extraction of natural gas, petroleum, crude oil, etc. So I hope we are aware that how it is done. So basically, just to give you an idea about it, how is it that the extraction of hydrocarbons is done? So where is it that the hydrocarbons are present? First of all, petroleum and natural gas. Are we aware of that? That in which part are these present? No. Okay. Very good. Underground. That is the best answer that I received. So here, When we talk about the hydrocarbons, they are basically petroleum, natural gas, etc. They are trapped within the permeable rocks, the porous rocks. That is where they are trapped, because petroleum, crude oil, natural gas, they are created by the fossilization of marine organisms, the marine species. So many of the times you will find these hydrocarbons to be trapped in the permeable rock structure. Okay. Trapped in the permeable rock structure. Now, in order to extract this hydrocarbon, what is done is holes are drilled. Holes are drilled and pipes are inserted. So, when this is done, immediately, if let's say, if you talk about the regions such as Kuwait, many of the areas in Middle East, where the so much amount of hydrocarbon is present at very shallow depth that even the digging of the holes in many of the cases pushes that crude oil upwards. But in general, that is not what is done. In general, what is done is, in order to extract these hydrocarbons, you insert two pipes. From one pipe, you push in high pressured air and water. So this goes with a very high pressure, and this in a way forces all the hydrocarbons, gas, etc. to emerge out of it. And that is where extraction is done. But then it is not a smooth process, because all those hydrocarbons, they try to fit in through the region of that pipe which has been drilled, the pipe which has been installed. So obviously this is not going to be a smooth procedure. Imagine if you have 100 students in your school, in your college days, whichever is easier to imagine, relate to that. You have 100 students, all of them trying to get out of the door at the same time, and it is a kind of a wooden door. What will happen? The door will break because so many people are trying to come up at the same time. Similarly, in the case of this as well, as this tries to come out with such great force, many of the times it leads to shaking of the earth's surface. But that shaking is initiated because of our human actions, and that is where the impact will also be in a restricted area. So whenever that extraction process is to be carried out, that region is vacated, and then the extraction is carried out. So it is a category of induced seismicity. Then you also have an induced seismicity experienced due to the dams, the construction of very large dams. How? So when you have a large dam, the construction of a large dam, let's suppose, how is it that the dam is constructed? So a large dam, you will observe, generally has got a very large concretized structure as a barrier, as a barricade, and then here you will have the water which is stored for hundreds of meters and so on. Water is significantly stored here. Now, this concrete structure, along with all that water, will they be exerting weight on the ground, or will the ground be able to handle that easily well? What do you think? They will be exerting a kind of a deformatory weight on the ground. So when that huge weight is imposed, very high amount of weight is imposed by that water column as well, many of the times the rocks get deformed. Okay, rocks get deformed and develop a crack. Okay, they end up developing a kind of a crack. Now, further exertion of the weight, and also in the case of dams, what also happens is some amount of that stored water that will also start percolating through here. Now, when the water enters the cracks, it will provide a kind of a lubrication for the movement of the rocks with respect to each other. So the rocks will always try to move. And anyways, even if they are generally just deformed, that is where also they will initiate some kind of action in order to regain their natural state. So due to that, oftentimes an earthquake is initiated. Example, you have the Koyana Dam disaster. Koyana earthquake due to the Koyana Dam. Okay. Then you have induced seismicity observed. So where is Koyana? Look at Koyana Dam first of all, and Koyana is actually a tributary of river Krishna. If we are not aware, that is the river for which Koyana is a tributary of. So it was a dam which was constructed there in the 60s, and that is when this particular disaster happened. Then you have the mining operations. Now, many of you would be belonging from the mining towns of the country. So, if ever you have resided or lived in a mining town, you would have understood that how this mining operation is carried out. Basically, you have the large rocks within which the minerals are included. Now, you have to extract those minerals. How do you do that? So, you carry out controlled blasting. You blast out those rocks with the help of dynamites and explosives. You plant those explosives and dynamites, and then you carry out controlled blasting at the underground level, on the surface level. Whenever that blasting is carried out, that leads to a kind of a shaking of the earth's surface. Generally, in majority of the mining towns in our country, you will observe that there are different times allocated for blasting, where everybody is made aware of that on a daily basis. You will have a blasting carried out at 3 p.m. in the afternoon, at around 10 a.m. in the morning. So that controlled blasting will take place. So this is because of controlled explosion. Right. That ends up shaking the Earth's surface. So that is basically how the induced seismicity can occur. It can occur as the hydrocarbons are getting extracted, shaking the Earth's surface. It can occur because of the weight imposed by the dam, deforming the rocks trying to come back to their original position. They will also end up shaking, or development of cracks in the rock structure due to the weight imposed. That can also induce a kind of a motion against each other, or controlled blasting during the mining operations. Now, after this, we come over to the portion of volcanoes. Now, when we talk about volcanoes, these are one of the most visually appealing images and views that you will get across the entirety of the planet Earth. And volcanoes, they have been very instrumental in creation of the various landforms that we see around us. The volcanic eruptions which happened at the time of the formation of the planet, now not even a fraction of those volcanic eruptions happened, because at that point of time when the planet was unstable, you had very frequently hundreds and thousands of volcanic eruptions which would rock the entire region. But now that is not the case. So still you have volcanic eruptions which do occur. But whenever these volcanic eruptions they do occur, that ends up creating its own different types of phenomena, where molten materials they come out from the interior of the earth's surface. So it is also a direct source of information about what the interior consists of. And there you have a kind of a large area or a large chamber in the interior where the molten materials they accumulate, and they end up coming up. Why? Owing to the pressure applied by the gases. The gases are very instrumental in providing that pressure, in bringing all the materials upwards. So that is where volcanic eruptions will always have a release of huge amount of gases. And amongst the gases, which is the most predominant gas which is released during a volcanic eruption? Are we aware of that? Whenever a volcanic eruption occurs, very good, Kambapati and Nidhi, it is basically water vapor. Water vapor is the most predominant gas which is emitted, which is released whenever you have a volcanic eruption. So overall, a volcano is a vent in the Earth's crust through which heated materials consisting of gases, water, lava, and fragment of rocks are ejected from the interior to the surface of the Earth. Okay, so fragments of rocks, lava, all of them, they are ejected from the interior. So basically, think about it as a feature like this. You have the molten materials, let's say, stored here. Now, as long as the molten materials are present in the interior, they are referred to as magma. As soon as they appear on the surface, they are referred to as lava. Okay, so this is what you have as magma. This is referred to as magma chamber. Now, along with the gases which have been trapped inside, let's suppose the molten materials, they come up. They come up, they will solidify here, right? Again, after a few years, again they will come up, again they will solidify further. So like that, eventually what you will observe is a creation of a kind of a volcanic landform, which is of a mountain shape, where you will find the presence of a volcanic vent. So this is what is referred to as a volcanic vent. Okay, this is your representation of a volcano. Now, this is your representation of a volcano. Now, what or why the volcanic eruption occurs? We have seen earlier in the case of convergent plate boundaries and divergent plate boundaries why this occurs. Where does it occur? What is the constitution of magma? How does it occur? Types of volcano. That is something we will study on Monday. So that is all that we will be studying for today. And I hope the session was helpful to you guys. Tomorrow we will have the tests, the objective and the subjective test, which shall be uploaded from the portions that have been covered up till now, the modules that have been covered up till now. You will find a couple of questions put in also from the portion of volcanoes. Ignore those. Take the rest of the questions. Now, the effort of the test tomorrow should not be to score the maximum. The effort should be to understand what kind of questions can be asked from this particular area, to understand which are the areas that you have covered and still committing mistakes. So I don't care even if you score zero in those tests, as long as you learn something out of it, as long as you improve something out of it. Okay, so it will be uploaded on the students portal. So that will be all from for the session here today. Let us take a few questions now. Do you take Hindi classes also? No, my dear friend, no. When we cover alpine, Himalayan belt, and S wave types, what do you mean by that? The different types of S waves are you talking about? The body waves. For general studies, only P and S waves are required to be covered. You don't have to go for the different types of S waves which are there. Different types of P waves are also there, but you don't need to cover that um, for your examination for general studies. And alpine Himalayan belt haven't we already covered? That why is it that there is a kind of frequent earthquake eruptions, earthquake occurrence happening there? Because in the region of the Himalayas, it is the Indian plate moving and pushing into the Eurasian plate. In the region of the Mediterranean, you have the African portion moving into and breaking into the Eurasian plate. That is where the Mediterranean Sea is going to be closed in the near term future. We have covered that, isn't it? Today, no, today we don't have, we won't be giving the map pointing. And Anurag, so you would have experienced the induced seismicity quite significantly. And There is a concentric circle in tsunami. How do they get formed? Okay. So when you have a kind of, let's say, any of these, take the case of the ripples in themselves. So when you have the ripples, the disturbance is happening only in one portion. But doesn't the water get disturbed in all directions? Similarly, in the case of the underwater earthquakes as well, the disturbance is happening in one region, but there will be a significant amount of ripples created all across. Other gases emitted during volcano include sulfur dioxide, methane, carbon dioxide, nitrous oxide in certain cases, carbon monoxide, and so on. Okay, Twisha, that is something I'll keep in mind. Um, Good that you pointed that out. Gaurav, love and Rayleigh waves, they are basically surface waves, the different types of shaking that the ground undergoes and experiences. Only the test will be there for you even to take up after the history class. Also, you can take up the test. Don't worry about that. And Lakshmi, in book and on net, it is 1.5 to 13 kilometer per second about the speed of the P waves, but in PPT it is 4.5 to 13 kilometers. So it varies, my dear friend. It is not something which is consistent. Rarely do you find a P wave which has got a speed of around 1 to 2 kilometer per second. But you can take any of those into consideration. Don't worry about that. That is not where UPSC is going to single you out. Adita, what is your question? Please ask. Can surface waves pass through liquid and gaseous mediums? No. They will generally be disturbing the solid surfaces itself. If there is a liquid or there is a water body on that solid surface, that will be disturbed. As the solid surfaces, they get disturbed. Okay. Despite the fact that Himalayan region is prone to earthquake, why are the dams and other construction are on a large scale? So large scale dams are not being constructed by India anymore. It is China which is constructing those large dams in the region of Brahmaputra. India is constructing run of the river projects where rather than having those large dams, you divert the water through a tunnel and generate electricity and supply that water back into the river channel. Okay. And how snow develop not exist. Okay. So circum-Pacific earthquake belt, Aditya, is basically the region around the Pacific or the Pacific Ring of Fire that we had studied, where you have frequent occurrence of earthquakes and volcanoes because of convergences happening from all direction. Oceanic convergence and oceanic continental convergence. That is the circum-Pacific belt. Are the landslides the result of an earthquake? Many of the times they are, but not always. Um, Shahid, Rayleigh waves are significantly dangerous. Classification will do that. The Himalayan region, they are more prone to earthquakes. The Gujarat region is more prone to earthquakes. That basic will also do. And why shadow zones are formed is because the waves are not able to travel in a straight path. They will get bent as they experience or as they come across materials of different density. Mercalli scale, Aniket, is basically a classification done for the earthquakes based upon the amount of damage that is caused by them. Okay? Yes, Anu, that is correct. Dams, when they create the induced seismicity, so basically that is because of the weight imposed by the dams. The weight imposed is so huge by the dam structure and also the water stored that it will lead to the deformation of the rocks, and when the rocks try to come back to their original place or original shape, that will lead to shaking. Hydrocarbon extraction is taking place by pushing in high pressure air and water through into the permeable rocks or the porous rocks where all this natural gas and crude oil is trapped, so that this natural gas and crude oil is then pushed out and forced from the narrow extraction portion, and that is where it comes out with very high amount of pressure that leads to shaking of the surface. Okay. Difference between love and Rayleigh waves is basically, Vikram, restricted to the kind of shaking that the earth's surface witnesses. So just like in the P and S waves also, you had the particles just witnessing different kind of motion. Here also, in the case of Rayleigh waves, you have a kind of a vertical undulation. In case of a love wave, you have horizontal undulation. Okay. Chandrasekhar, that will happen only once you start covering the revision of the current affairs. You will start looking at each one of them. Earthquake zones of India in detail, no, it is not required to be covered in further detail. Even this much is more than sufficient for your general studies. It is in optional that you are required to give the exact regions of where the faults exist, not in the case of general studies. Okay. And volcanoes are not always in triangle shape. We will study about that coming Monday. So that will be all from my side this week. So we meet again on Monday. Till that point of time, take care of yourself. Goodbye. Thank you and good night.